In an earlier lesson, we looked at a problem like this, where you are given a particular picture and you're asked, what is the measure of the angle that is drawn there? And you give it in degrees, you give it in radians. So we talked about how it looks like, well, this is more than 90. It looks like, in fact, it's probably about halfway between 90 and 180. And so we'd estimate that that's about 135 degrees. Or when we talk about radians, we talked about how, well, zero's over here, pi is over here, and it looks like we're going about 3/4 of the way to get to pi. And so we could also say that it's 3/4 of pi by saying 3 pi over 4. The only little detail with this, though, is that we talked about that as the measure of the angle, and it's actually not the measure of the angle. It is only a possible measure of the angle. In fact, there's an infinite number of ways that we could describe this particular angle measure, because we always assumed that we are just going along this section. But what if we weren't? What if instead we went all the way around the circle and then we went to get there? That would totally change what that angle looked like. Well, let's actually figure out, what would the angle be if I did it that way? What if I went around the entire circle in extra time? Well, the entire circle in degrees, so let's work with degrees first. The entire circle in degrees is 360. So I could do 135 plus 360 to be able to figure out where that angle is. And if I actually do that, that ends up giving me 495 degrees. So 495 degrees is another possible answer for that. That's the exact same angle. It ends at the same spot on the circle. And in fact, if I wanted to, I could figure out all sorts of other ones where we could figure out how else we could get there by doing, say, 495 plus another 360. And that number plus another 360, and that plus another 360. And all that does is represent that we could keep going around the circle over and over and over again, as long as we still ended up at that same point, that same angle on the circle. Now, we also could do that in radians. In radians, we're going around an extra full time around the circle, right? Well, what is a full circle in radians? Well, hopefully you remember that part. I know that's fairly new. The full circle in radians is 2 pi. And so I could end up doing 3 pi over 4 plus the 2 pi. Now, when I did that over here, I could actually add them together because they were nice, pretty little integers. And with this one, you can actually add them together by like getting a common denominator and a bunch of stuff like that. But I'm going to tell you right now, you don't have to right now. You could actually just leave it like that for now, which in some ways can actually make our lives a little bit easier, because if you wanted to go around again, that'd be 3 pi over 4 plus 4 pi. That'd be going around the circle twice before you got to our 3 pi over 4. Or you could do 3 pi over 4 plus 6 pi, or 8 pi, or 10 pi. Notice the key is just that this number has to be a multiple of 2 pi. And so by doing that, we can end up with all of these different angles that actually end at the exact same place on the circle. In each of those examples that we were just looking at, though, we always assume that we are starting at 0 and going counterclockwise, because that's how we normally measure the angle like that. However, we could also try going the other direction. If I start at 0, but then go clockwise from there, then I'm actually going the wrong direction, right? What that means is that I can actually measure my angle with a negative degree. So it's like I'm taking my 135 degrees that I had up here, and I'm actually subtracting 360 degrees to get to another angle that has the same location on the circle. So if I do that, that gives me an answer of negative 225 degrees. So you'll notice then this angle that we've been looking at here, it could be 135 degrees. It could be 495 degrees. It could also be negative 225 degrees. Or we could keep going along too. If you wanted to do negative 225 degrees minus 360 degrees, that would give you another answer about what it's equal to. And all of those are really representing the exact same angle. They're still talking about the same final location here on the unit circle. Now, again, I just did that with degrees. If I were in radians trying to accomplish the same thing, instead of doing 3 pi over 4 plus 2 pi, I could do 3 pi over 4 minus 2 pi, or minus 4 pi, or minus 6 pi, or minus any multiple of 2 pi, and it's going to be able to get me to that same location. Now, these angles that all have different numbers but are actually representing the exact same location on the circle are called coterminal angles. Co means together, right? Terminal means where it ends. So coterminal angles are angles that stop at the same location on the unit circle. It doesn't matter how many times we went around the circle in order to be able to get there, as long as we end in the same spot, the angles are considered to be coterminal. Now, we talked about how we can know how far apart these angles are, right? If I had an angle like 135 degrees and I wanted to find coterminal angles with that, I could go ahead and just add 360 degrees, right? Except I don't want to just say they're always 360 degrees apart, because remember, I could add 360 multiple times. So they might be, let's say, 720 degrees apart or something like that. And so what I'm instead going to say, instead of just 360 degrees apart, I'm going to say 360 n degrees apart, where n is any integer value. Okay, and I'll come back to that idea here in a moment. What if we are going to be taking a look at it in terms of radians? How far apart are the radian measures? Well, that'd be the full circle, right? So the full circle in radians is 2 pi. And so if I want the entire thing, I multiply the 2 pi also by n. Now, n is any integer. Now, remember our definitions of different types of numbers? An integer is basically like a whole number. So we're saying that it does not have a decimal with it, except that an integer can also be 0 and it can also be negative. So notice I can multiply it by anything that doesn't have a decimal or fraction with it, and then that will get me to a coterminal angle there, as long as I'm using that for those n values along the way. And yes, this again would be something good to write down and have in your notes so you can reference it as you go forward.